Humanity has long gazed upward, our telescopes piercing the veil of the cosmos in a tireless quest for signs that we are not alone. For centuries, we've scanned the stars, hoping for a whisper from distant civilizations, perhaps a radio signal, a flash of light, or some anomaly that defies natural explanation. We've listened to the silence of space, our instruments attuned to the faintest echoes, dreaming of contact that could redefine our existence. Yet in a twist that echoes the greatest science fiction tales, the breakthrough didn't arrive from a far-off galaxy or an ancient alien beacon. It emerged right here in our own solar system, courtesy of an interstellar wanderer that has captivated astronomers worldwide. The comet known as 3I/ATLAS, discovered on July 1, 2025, by the NASA-funded ATLAS survey telescope in Chile. This enigmatic visitor from beyond our stellar neighborhood has shattered expectations with its sheer mass and unusual behavior. Weighing in at over 33 billion tons, far exceeding the mass of previous interstellar objects like Oumuamua and Borisov, this comet isn't just a fleeting guest. It's a colossal enigma hurtling through our cosmic backyard, prompting questions that keep scientists up at night and viewers glued to their screens. As we delve deeper into this unfolding mystery, imagine the thrill of witnessing history in real time. What if this interstellar comet, with its emerald-hued coma and rhythmic pulses, isn't merely a chunk of ice and rock? What if it's something more, a harbinger of cosmic secrets? Stick with me through this journey, because by the end, you'll see how recent discoveries on Mars tie into this narrative in ways that could rewrite our understanding of the universe. We'll explore the real science behind the speculation, drawing on the latest data from NASA's missions, and build a case that's as engaging as it is thought-provoking. But first, let's set the stage with the facts. The story of 3I/ATLAS begins with its detection amid the vast expanse of space. Unlike typical comets born within our solar system, this one originates from interstellar space, making it only the third confirmed interstellar object to grace our vicinity. Initially designated as A11PL3Z, before earning its comet moniker C/2025N1ATLAS, it was spotted streaking toward us at incredible speeds, its trajectory confirming an origin far beyond the Oort cloud that encircles our sun. Astronomers were immediately struck by its size. Hubble's observations in July 2025 estimated it to be vastly larger than anticipated, prompting debates about its composition and why it's so anomalously heavy. But it wasn't just the mass that raised eyebrows. Early spectra revealed an unusual emerald glow, a luminescence that pulsed in regular intervals, defying the erratic outgassing typical of comets. For months, teams from NASA, ESA, and independent observatories scrutinized this glow, its brightness waxing and waning every 173 minutes with clockwork precision. This rhythm suggested something structured, perhaps even intentional, though scientists cautioned against jumping to conclusions. Yet as data accumulated, the mystery only deepened, drawing in experts from fields as diverse as astrophysics, planetary geology, and even exobiology. Now picture this. As 3I/ATLAS sliced through our solar system, its path took it on a trajectory that brought it perilously close to the inner planets. But here's where the narrative takes a dramatic turn. Instruments worldwide, from ground-based radio telescopes to orbiting observatories like the James Webb Space Telescope, confirm that these pulses weren't random emissions dissipating into the void. They were directed, focused beams of energy lancing straight toward Mars. This revelation, emerging from coordinated observations in August and September 2025, left the scientific community reeling. The energy spikes, carrying wavelengths in the visible and radio spectra, penetrated Mars' thin atmosphere, igniting brief shimmers of green light visible even from Earth-based telescopes. At first, skeptics attributed it to solar flares or atmospheric interference, but repetition sealed the deal. Identical pulses, same duration, same power, all aimed unerringly at the red planet. Humanity had stumbled upon evidence of an interstellar object, seemingly communicating with a world we've long studied but never fully understood. And then, in a moment that echoed through observatories and online forums alike, Mars responded. This wasn't mere reflection or echo. It was a transformation of the signal. Orbiters like NASA's MAVEN and ESA's Trace Gas Orbiter detected electromagnetic bursts emanating from Mars, matching 3I/Atlas's frequency, but modulated with subtle variations, shifts in phase and amplitude that hinted at intentional encoding. These responses came swiftly, within minutes of the incoming pulses, as if the planet were engaging in a real-time dialogue. Earth-based arrays, including the Very Large Array in New Mexico and the Square Kilometers Array precursors, picked up faint harmonics rebounding across space, amplified by Mars' own emissions. To analysts poring over the data, it felt like eavesdropping on a cosmic conversation. 3I/ATLAS, posing a query in pulses of light and energy, and Mars replying in its own resonant voice. This exchange, unfolding in September 2025, challenged everything we thought we knew about the red planet, a world presumed dead, silent, and barren for eons. To appreciate the profundity of this event, we must rewind to the rich history of Mars exploration, updated with the very latest findings as of September 30th, 2025. Humanity's fascination with Mars dates back millennia, but our modern understanding stems from a fleet of robotic emissaries. NASA's Perseverance rover, which touched down in Jezero Crater on February 18, 2021, continues its mission, having traversed over 25 kilometers by now, and collected dozens of rock samples. Just this month, on September 10, 2025, NASA announced a groundbreaking discovery from Perseverance, a rock dubbed Chayava Falls, bearing leopard-like spots that suggest potential biosignatures, signs of ancient microbial life. These features, including organic compounds and chemical reactions indicative of life, have ignited global excitement, with peer-reviewed papers confirming the rock's minerals, like vivianite, point to past habitable environments. Meanwhile, the Curiosity rover, active since 2012, soldiers on in Gale Crater, recently navigating rugged terrains like the Audubon Ridge, providing data on Mars' geological evolution. But it's the seismic insights from the now-retired InSight lander that add layers to our story. InSight, which operated from 2018 to 2022, detected over 1,300 Marsquakes, and recent analyses in 2025 have revealed a lumpy mantle and a solid inner core approximately 600 kilometers in diameter. These quakes, caused by internal stresses and meteor impacts, propagate waves that map the planet's interior, showing unexpected heterogeneities, clumps of denser material that could influence how energy resonates through the crust. In our narrative as 3I/ATLAS's pulses struck Mars, these seismic monitors, though InSight is offline, its data legacy informs current models, registered rhythmic tremors synchronized with the incoming signals. These weren't chaotic shakes, but patterned vibrations delving into the mantle, as if Mars' very geology was harmonizing with the comet's call. Spectrograms of these waves translated into visual patterns, spirals, hexagons, and triangles mirroring the luminous geometries observed in 3I/ATLAS's coma. This synchronization hints at deep subsurface structures, perhaps ancient voids or resonant chambers, activated by the interstellar signal. The implications ripple outward, touching on Mars' atmosphere in its ethereal displays. Recent breakthroughs have shown that Mars hosts auroras, not just ultraviolet ones detected years ago, but visible light phenomena glowing green across its skies. In May 2025, Perseverance captured the first surface image of such an aurora at a wavelength of 557.7 nanometers, confirming that future astronauts could witness these spectacles with the naked eye. Scientists can now predict these events, linked to solar storms interacting with Mars' tenuous magnetic remnants. In our enhanced tale, as the dialogue with 3I/ATLAS intensified, these auroras amplified, shimmering in structured patterns, concentric circles, ladders, and infinite spirals, aligned with the pulses. The red planet's atmosphere became a canvas, projecting mathematical constants and symmetries that echo human architectural designs, from the golden ratio to ancient geometries. This visual broadcast, visible from Earth, transforms passive observation into active engagement, suggesting the message isn't just for Mars, but perhaps for any watchful eyes in the system. Phobos and Deimos, Mars' diminutive moons, add another chapter to this cosmic saga. Long debated as captured asteroids, recent 2025 studies confirm they likely form from debris of a massive impact on Mars itself, not gravitational theft from the asteroid belt. Spectral analyses compare their surfaces to Martian terrains, and new ephemerides refine their orbits, noting Phobos' gradual spiral inward toward eventual disintegration. Infrared images from NASA's Europa Clipper in February 2025 captured heat signatures from both moons alongside Mars, highlighting their thermal properties. In the narrative, when 3I/ATLAS's signal hit, Phobos reflected synchronized bursts, acting as a relay, while Deimos glowed with intermittent emerald flashes. Phobos's orbit subtly adjusted, fissures of light cracking its surface, as if awakening latent mechanisms. This activation posits the moons as integral to Mars' system, perhaps engineered relics waiting for such a trigger, blending real orbital dynamics with speculative wonder. The rovers on Mars' surface provide ground truth to this unfolding drama. Perseverance and Curiosity, both operational in 2025, have weathered dust storms and technical glitches. But in our story, as pulses peaked, their feeds glitched with green static. One transmitted corrupted data, embedding prime number sequences matching 3I/ATLAS's patterns before going silent. A fictional echo of real communication challenges like signal interference from solar activity. Engineers' frantic commands yielded no response, suggesting the machines were entrained in the resonance, their electronics echoing the cosmic signal. This humanizes the tale, reminding us of our technological vulnerabilities amid vast interstellar forces. As the exchange escalated, Earth felt the ripples. Radio telescopes detected faint bursts mirroring the Martian responses, laced with prime sequences and logical structures akin to SETI's proposed universal languages. Blackouts plagued global arrays, timed with pulses, leaving green noise artifacts, echoes of real 2025 disruptions from solar flares, but amplified here for drama. Green auroras appeared in unlikely locales, pulsing to the rhythm, as amateur operators captured melodic tones in static. This spillover draws Earth into the dialogue, posing, "If Mars answered, might we next?" Delving into history enriches the narrative. Ancient myths portray Mars as a god of war. Roman Mars, father of Romulus and Remus, symbolizing military might and protection. Sumerians, Egyptians, and Mayans wove tales of red stars, green fires, and celestial serpents linking orbs with beams of light. Greek Pyroes, the fiery star Mars, ties to wandering planets in mythology. These stories, once symbolic, now parallel 3I/ATLAS's cycle. Twin fragments, real comet observations, suggest potential splitting. Green whispers awakening the red world. If ancestors witnessed similar events, this isn't novel but recurrent, a cosmic cycle reshaping worlds. Expanding on implications, consider exobiology. The Chayava Falls discovery fuels speculation. If past life existed, could dormant forms resonate with signals? Seismic voids hint at subsurface oceans or structures, potential habitats activated by energy. Atmospheric layers, kaleidoscopic in ESA images, could harbor exotic chemistry responding to pulses. Future missions amplify stakes. SpaceX plans Starship launches to Mars in 2026, gathering entry data. Sample return from Perseverance via NASA-ESA collaboration could confirm biosignatures. If 3I/ATLAS's dialogue persists, these ventures might intersect with active phenomena, offering first-hand views. Government silence, NASA's cautious releases, fuels conspiracy whispers. But transparency prevails in science. Independent findings spread online, spectrograms vanishing mysteriously, echoing real data security concerns. In conclusion, 3I/ATLAS's arrival, Mars' response, through quakes, auroras, moons, spills to Earth, blending fact and fiction in a tapestry urging us to watch. What if this cycle heralds awakening? Stay engaged. The universe's next pulse might be for us.